Write the rational number in simplest form, which represents the trigonomic ratio. In this question, they want you to write the sine, the cosine, or the tan, the trig ratio, that relates to the angle in question. And what they're going to do is they're going to change the angle with each question. So for the first one, they want the sine of angle x. Now there's two triangles here, so I just looked for the angle labeled x. Now the sine of that angle is going to be equivalent to the opposite side, or the side across from it, and the hypotenuse of the triangle, the one across from the 90-degree angle. So I'm always going to use those SOHCAHTOA rules. It's always going to be opposite over hypotenuse. In this case, the opposite side, or the side opposite to the angle x, is 6, and the hypotenuse of that triangle is 10. And of course, when I reduce that, that's going to be 3/5. Now I'm going to erase the work I did on that because I noticed the next question asks for a different angle. And if I change the angle in question, I'm going to change which side is considered opposite or adjacent. So for part 2, they're looking for the tan of angle y. So as I change angles, the opposite and the adjacent sides change. So from angle y, the opposite side, the side directly across from it, is 8. And the adjacent side, the one touching it, is going to be 6. So I'm going to reduce that to 4/3. And remember, leave that as an improper fraction. Don't change it to 1 1/3. Okay, the next one, cosine of angle A. Now in that first triangle, there was no angle labeled A. I see that in the second triangle. So cosine is equal to the adjacent side over the hypotenuse. Now remember, the hypotenuse is the one that is across from the 90-degree angle. So I would never consider that the adjacent side. It's always going to be the hypotenuse. That's the one side that won't change. So in relation to the A, since the 13 is the hypotenuse, then I know for sure the 5 must be the adjacent side. So 5/13. And that one can't be reduced, so I'll leave that. Let's erase some of my work there to do the next one. So the tan of angle B, that's in the second triangle as well. In relation to that angle, they want the opposite side over the adjacent side. Now remember, 13 can't be adjacent because it's the hypotenuse. That's the only side I could label in this triangle that will always stay the same no matter which angle I'm looking at. But the opposite side is going to be 5. And for tan, I need opposite over adjacent. So the side touching it is 12. That's the adjacent side. Okay, let's move on to the next one. The sine of angle y. So here's angle y. We already did the sine of angle x. So in this case, again, we're going to go opposite over hypotenuse. The side across from the y is 8, and of course the hypotenuse of that triangle is 10. And always reduce if you can. For the next one, the cosine of angle x. So I have to move my pen to the x, find out which side is adjacent and which side is the hypotenuse. Since 10 is always the hypotenuse, it wouldn't be considered the adjacent side. So that must mean 8 is adjacent and 10 is the hypotenuse. So I'm actually at 4/5 again, and that's a 4. And to do these last two, I'm just going to erase some of my work again. Okay, the cosine of angle B is going to be equal to the adjacent side over the hypotenuse. So 12/13. And that can't be reduced, so I can leave it as is. And the last question is the sine of angle A. So I look at a different angle. The sine of that angle is going to be equivalent to the opposite side over the hypotenuse. So I got 12/13 again.